Hello, this is another thinking and communication problem for you. Now here, we need to determine a possible expression for fx in which fx is a quartic function, that means degree 4, with following properties. Fx is greater than 0, that means positive, on the interval from -4 to -1, and fx is less than 0, that means negative, on the interval -infinity to -4, 1 to 3, and 3 to infinity. Correct? Let's try to understand this problem. First, we need what? We need a quartic function. And what is happening to this quartic function? It is positive only in the interval -4 to 1. Those points not included. So at those points, we could have 0, okay? Now, and this is negative in the interval from -infinity to -4, from 1 to 3, and 3 to infinity. It makes it clear that at -4, 1, and 3, we have a 0, correct? Now, let's try to figure this out by making a rough sketch. So, let's first consider our zeros. Zeros are at -4. Let's say this is -4 for us. And 1 and 3. So, let's say this is 1. And let's say this is 3 for us. Now, fx, the function, is positive. In which interval? From -4 to 1. So, in this interval, value is positive. Do you see that? And elsewhere, it is negative. Everywhere else, it is negative. It could be 0 at those x-intercepts. Now, if you need to draw a quartic function, then one of these roots should have multiplicity of 2, correct? 1, 1, 1, it gives us 3, right? So one of them should have multiplicity of 2. Well, the function says quartic, that means end behavior is negative. Now here it is negative on these sides, therefore we can safely say that the end behavior is like this, correct? That means the leading coefficient has to be negative, okay? Now if you go up straight, kind of like this, you can go like this, come back, go like this, then you reach there. You don't come here. Do you see that? Correct. So if you have to come here, you need a turning point. That means a 0 of degree 2. Now, it seems to be very obvious that if you go from here, well, from negative, you went to positive, and you remain there in positive, correct? And then you come back, you can't go back because you're negative in this region. So you come back and then bounce back. That seems to be a good proposition. So let's do like this. So let's go like this, come back, so that's positive and that's negative. And here we turn and then go to our infinity. So we move to this. That seems to fit our given conditions. Do you see that? Now the question is to find a possible expression. Do you understand? Possible expression should be what? Now let's use these values and find an expression. So we say fx is equal to these roots, right? X plus 4. Multiplicity is 1. It just crossed like a line. Here again, multiplicity is 1. And the root is at 1. So we'll have x minus 1 as our factor. How about this point? X minus 3, but it bounces back. And we need quartic. 1, 2, 3, 4. Quartic means degree 4. Now we get degree 4. Now this number has to be negative, isn't it? If it is negative, then the function will have end behavior as shown above. It is going from quadrant 3 to quadrant 4. Why it says possible expression? I could write -1, -2, -3, any value. How will I exactly get a value? Provided I have the value of this point, y-intercept. If I plug in 0 for x, and I know that point, then I can find the value of a. I'm not writing a purposely here, okay? A gives me family of all possible expressions which fit into this particular description. Well, if I have to be very specific, And because no other criteria is given to us, I can simply write minus all this, or I can write minus 2 times all this, whatever. But I get the condition required for the given problem. Okay? So this is how we draw a graph and get the equation from given conditions. Correct? You can check it once again. Fx is positive on the interval minus 4 to 1. So from minus 4 to 1, we are positive above the line. Do you see that? So here, fx is positive. Okay? Now, it is negative elsewhere. Nothing has been mentioned about the points 4, 1 and 3. It is assumed to be 0, of course. Correct? So that's the perfect equation for our function. Okay. Thank you.